We've got another theorem about perpendicular lines that we're going to take a look at, and this one has a name. It is called the perpendicular transversal theorem. Perpendicular transversal theorem. And so, as you might guess from the name, it has to do with perpendicular lines, and particularly transversal. Whenever we talk about transversals, we're generally talking about parallel lines, and so that's what's the case here. So it says that if a transversal is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Then it is perpendicular to the other. Okay. So, just like before, we'll need a diagram here to work this through. So we've got, well, it says if a transversal is perpendicular to one of two parallel lines, so we need two parallel lines. Here we have two parallel lines, and we actually know that they're parallel, not just they look like they're parallel. I'll call them P and Q, and we'll mark them as parallel. And then we have a transversal that is perpendicular to one of them. Call this T. We want to be able to show this perpendicular to the other as well. So let's go ahead and write our givens. So my givens, if I read this, my hypothesis, so if a transversal is perpendicular to one of two parallel lines, so I need two things, the parallel lines and the perpendicular part. So I need that P is parallel to Q, and that T, my transversal, is perpendicular to just one of them. So T is, that's not what I wanted, T is perpendicular to P. And then what I will want to prove is that it's also perpendicular to the other line. So T is perpendicular to Q. So go ahead and write this. I'll write my givens. P is parallel to Q. Also, T is perpendicular to P. Both of my givens. And now that I have those down, I can put some thought into this. So, how do I know this will be the case? Well, this is going to be a pretty straightforward proof, actually, that has to do with right angles. So if I know that T and P, if they're perpendicular to each other, what that means is that they have to form a right angle. And since these lines are parallel, what I'll be able to do is say that, well, the corresponding angle to whichever one I talked about being right up here will also be right down here, thus making it perpendicular. The only issue is that we're going to have to talk about measures, which is a little bit tedious, of course, but it's fine. We'll work through it. It'll be no big deal. So let's go ahead and start with that. So I need to talk about an angle. Maybe I should label one of these. I'll label this angle 1 and this angle 2. And so I need to talk about angle 1 and the fact that it's right. So angle 1 is a right angle. How do I know that? Well, it is the definition of perpendicular. Whenever I have two lines that are perpendicular to each other, they have to form a right angle. So two lines are perpendicular if and only if they form a right angle. Angle. There we go. Where did that come from? That came from 2. And so naturally, well, actually maybe not naturally, but I want to connect 1 and 2 together. So I'm going to end up having to talk about measure, so I might as well just do that right now, where I can talk about that the measure of angle 1 is 90 degrees. So how do I know it's 90 degrees? Well, it's a definition of being a right angle. So an angle is right if and only if its measure is 90 degrees. That comes from 3. Okay, so now I need to talk about this linking here. What I'm going to say is, well, 1 and 2 I know how to be congruent to each other. The reason I know is because they're corresponding angles on the same transversal for these parallel lines. So that'll be my next statement, the fact that angle 1 is congruent to angle 2. They are corresponding angles. And so what I'll say is that if two lines are parallel, then their corresponding angles are congruent. That comes from, where did I say they're parallel? All the way back up in 1. Okay, so now I'm really close to being able to link 2 with the fact that it's 90 degrees. But my issue is right now I have a statement of congruence and a statement of equality. I need them to be both the same thing. And obviously I can't have an angle being congruent to a degree measure, so I need to be able to state this in equality. So what I will say is that the measure of angle 1 is equal to the measure of angle 2. How do I know this? Definition of congruence. Two angles are congruent. If and only if their measures are equal. That comes from 5. And then now I can actually link these things together. So I have the measure of angle 1 is 90 degrees. I have the measure of angle 1 is also equal to the measure of angle 2. Since these two things, 90 degrees and measure of angle 2, are equal to the same thing, they'll be equal to each other by the transitive property. So the measure of angle 2 is equal to 90 degrees as well. So this is statement 7. This is just a transitive property. And so it's kind of interesting now. Well, let me actually finish this out, 4 and 6. It's kind of interesting because what I started with was perpendicular, right angle, had a measure, linked them together. Now I have a measure. What I'm going to have to work my way back to is right angle and then to perpendicular. So I kind of worked my way down the ladder and now I'm working my way back up. And so statement number 8 then is the fact that angle 2 is right. So it's like I'm going to give all my same reasons, just now in reverse, because a lot of these were definitions. So statement number 8 is the definition of a right angle, and angle is right if and only if its measure is 90 degrees. Comes from 7. And then finally I can say that line T is perpendicular to line Q, and that again will be the definition perpendicular. Two lines are perpendicular if and only if they form a right angle. Right angle, I think I left out and right angle, that's just a mess. No, I didn't. From right angle, I don't know what I'm doing anymore. Angle, there we go. I linked that back to 8. Okay, oh, because I didn't write, okay, I don't know. Grammar's hard. So let's just talk about what I did here again, because again, I think it's kind of interesting. So I used all the same reasons, just in reverse, where I said perpendicular to right angle to 90 degrees, and those are both definitions. I linked these things together using my definition of congruence, and I worked my way back up. I talked about the fact that if an angle is measures 90 degrees, then it has to be right, and if two lines form a right angle, then they have to be perpendicular. So I use the same definitions again, but since they're biconditionals, I can use them in reverse to allow me to prove this theorem. So what we were able to show here is that if a transversal is perpendicular to one of two parallel lines, then it has to be perpendicular to the other as well, which is actually a pretty useful theorem that we'll use in the future. Since we've now proved it, we can of course use it in future proofs.